Okay, good afternoon, everyone. This is Felicity in Nevada. All right. The issue with this in Nevada is that the customer complaint, the SMPS section of it is not coming up, and there's the SMPS section of it. All right. So it's not coming up. So here is the interface for the SMPS. You know, to provide the auxiliary power supply for the driver IGBT, for the main control card, for the fan operating voltage. All the voltage comes from this SMPS. Alright. Okay, if you look closely, you will see there are three sections of the SMPS there. Alright. This one is the soft start. This is the soft start. This is the soft start SMPS. Alright. So between these two is another SMPS, one for the powering on battery. Once you power on battery, one of the SMPS is meant to interface with the battery to power on battery, to power the main control card, provide the auxiliary voltage for all the fans, and also for the IGBT driver section. The second SMPS is going to be for in the case where the solar is connected. All right. Does it have a solar impulse? Okay, yes, there's a PV impulse. All right. So the second SMPS is meant to power the solar to pop up the power, whether in the absence of the battery or not. I think the second SMPS is going to take over the other SMPS that is working from the battery. So today, basically, I think the system is not coming up at all on battery. It's not being powered on battery at all. So we need to have a close look of the circuit, what is actually wrong. You know, in the system of this PCB, we have a double assembling here. All right, you have a double assembling here. You can see from the top layouts, you have all the component here. You have the main high frequency transformers. We have the three MOSFET here. These three MOSFET here work with individual high frequency transformer, you know. So there is going to be a blockage, you know, in the case where a battery is coming in, is not coming out. You know, it's only going to be outputting when it's being used. So there will be no feedback from the output to the input, and there will be no feedback from the input to the output. Beneath is the other layout where you have all the optocouplers, you know, for each of the sections to report, you know, to the main controller to know the voltage level and comparating level of the voltage to the circuit. So you have the feedback section, and also here you have the diodes. You know, we have a layout of the diodes and some other passive component like the resistors and the capacitors. Now the third thing again is the driver IC. You have the driver IC 1, 2, and the third one. So basically this is the driver IC here for the soft start. This is the driver IC. So in case you are facing the soft start issue, here is the driver IC. I think the IC should be I guess It should be maybe UC 3845 or UC 3843. You know, it's one of the conventional IC driver IC for most of the SMPS. So you have one here for the soft start. Okay, you have one here for the soft start, and you have another one here. You have another one here just for this. This one is meant for this. Why the third one, this one, is actually meant for this SMPS. So what we're gonna do is we're going to make sure that we test every component one by one, evaluate the status of the driver IC, the pulse width modulation IC, evaluate the status, correspond the resistor values, test every transistors, and we apply voltage to it. We apply the battery voltage to it. I think the system is 48 or what? Let me have a look. I think the system should be 48 volts. I think it should be 48 volts. Okay, the DC input here. Okay, so is the input DC is 48 volts. So we're gonna have a 48 volts DC to power this. Then we troubleshoot, and I'm gonna give you feedback on my next video. I'm gonna give you feedback. You're gonna see the outcome when it's done. And so then stay tuned. Don't go anywhere. I'll be right back.